Hello, in today's lesson our learning target is I can solve single variable equations. So we're going to be looking at single variable linear equations. So let's start with a simple example. Let's do x minus 9 is equal to 14. So what an equation tells us is that everything that's on this side of the equation has to be equal to everything on this side. So if you recall, in our last lesson we went over the properties of equality. And some of those properties of equality, namely the addition property, subtraction property, multiplication property, and division property, are really our tools in solving these equations. So if we look at the tools that are at our disposal, we can either add the same thing to both sides of an equation. We can subtract the same thing from both sides of an equation. So same thing from both sides. Or we can multiply or divide each side by the same thing. So the key point here is the same thing. So if we imagine we have a scale like this, it's a good way to think of an equation. Then suppose we have the scale's balanced, we have the same thing on both sides. If we want the scale to remain balanced, we would have to subtract the same thing from both sides. So there, I subtracted 2 from each side. If, say, I just add 5 things to this side and nothing to that side, our scale is going to look like this. So essentially, we want to keep our equation balanced. So in this case, or in all cases, we want to solve for x. So we want to get the x alone. So in this case, we're going to want to add 9 to each side. So negative 9 plus 9, we're going to get a 0 on this side. So we'll get x is equal to 14 plus 9, which is equal to 23. And we solved our equation. So this is a very simple equation. It's called a one-step equation because it only took one step to solve. You see, all we had to do was add 9 to both sides. So now let's do a second example. We'll make things a little bit more complicated. Let's do 2x plus 4 is equal to negative 14. So in this case, once again, we want to get that x alone. But our first step is we want to get everything with an x on one side and everything without an x on the other side. So we're going to use the subtraction property to subtract 4 from each side. Then we're going to get 2x is equal to negative 18. Now, so that step was kind of similar to this step, although instead of adding something to both sides, we subtracted something from both sides. Now, since this x is multiplied by 2, we're going to need to use the division property to reverse that. So when you have a number on top in front of the x, we're going to want to divide both sides by that number. So divide by 2. Those 2's will cancel out. We'll get x is equal to negative 18 over 2, which is equal to negative 9. And that is our answer. So this was a two-step problem. First we had to subtract 4 from both sides, and then we had to divide by 2. So we used the subtraction and then the division properties in order to solve this problem. So if we want to do another problem, let's do 1/6 x minus 2 is equal to 3. So in this case, the problem looks pretty similar to the last one, in that in our first step, we want to get this term with the x on one side, we want to get both of these numbers on the other side. So we're going to start out by adding 2 to each side. We get 1 over 6x is equal to 5. So now, instead of 2x, we have 1 over 6x. So when we have a fraction, we want to get rid of this 1 over 6, right? So the way we're going to do that is by using the multiplication property to multiply both sides of this equation by 6. And these 6's will cancel out. We'll get x equal to 5 times 6, which is equal to 30. And let's take a quick step back. The reason that we can do this works, is that when we're multiplying both sides by 6, we're essentially multiplying both sides by the fraction 6 over 1. And 6 over 1 multiplied by 1 over 6 is going to be equal to 6 over 6. And whenever we have the same number divided by itself, that's just equal to 1. So now we have x alone, or 1x, and on this side we have 30. So we have x equals 30, and we solved our equation. So those are a couple examples of some two-step equations. We're going to do one more that's a little bit harder for you guys to end the lesson. So suppose this time we have 4x plus 19 plus x is equal to 37 plus 2x. So now we have a lot more terms in this equation, but we're going to use the same methods. So first we want to do what's called combining like terms. So what this means in this case is we're taking any term that has an x in it, and we want to get those over to the same side. So I can start to do that by subtracting 2x from each side. We get 4x plus 19 plus x minus 2x is equal to 37. But wait a second. We don't want to forget about the 19 and 37. We also have to get these two terms on the same side. So we're going to move the 19 over to this side. I'm just going to draw this arrow to represent that we moved 2x over to this side. So in order to do that, we're going to subtract 19 from each side. And we get 4x plus x minus 2x is equal to 37 minus 19. So now you see we have everything that was underlined in blue on this side, and everything that was underlined in red on this side. And now that we have our like terms on each side, we can just add them up. So 4x plus x minus 2x is going to be equal to 5x, or no, 5x minus 2x is equal to 3x. And on this side, 37 minus 19 is equal to 18. And now, all of a sudden, all we have is one more step left to do. We have a 3 on the top. What do we do to get rid of that? We use the division property and divide each side by 3. 3's cancel out, and we get our final answer is x is equal to 6. So this problem had a couple more steps than the last one, but hopefully wasn't too bad. And I guess that concludes our intro to solving single variable linear equations. And in our next lesson, we're going to do a couple more examples of more complicated ones where we might have fractions or have to do even more steps. So stay tuned for that.